Hello students, and welcome to another video. I'm your teacher, Mr. Flynn, and today we're going to be talking about how to measure. Okay. In the lab, you're going to be using a variety of equipment, and you need to learn how to properly measure liquid or the length of something, etc. And we will be using graduated cylinders and scales, but in this example, I'm going to be using a ruler, okay? And as a reminder, we don't use inches, we use centimeters, okay? Now, to give us our first example of a ruler, I'm going to draw a 10 centimeter line here. I'm going to draw an ends to this. I'm going to draw 0 and 10. So this is the ruler that I just made a ruler, essentially, on my page. And what I'm going to do is I'm going to measure something, and I'm going to draw a green line. I'm going to put it in inches so I don't kind of guess. I'm just going to draw a line. All right. Now I want to measure this green line, and this is what I've been given, basically a ruler that's 10 centimeters in increments. And there's a couple ways that we can measure this. We could say it was either 0 or it was 10 because those are the only certain digits that we have. What about how could we divide this up to kind of guesstimate where this is? We could do it in halves, we could do it in quarters, we could even do it in thirds. But the way we want to do it in the lab is in tens. So if we think about from 0 to 10, where would this line be? Like, what is it? What if there were hash marks here that said 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, where would it land? And I would assume that this line would land probably around 6 or 7. Okay, and neither of those answers is correct because we're estimating. So everyone's going to have a little bit different of an answer. So I'm going to say 6 centimeters. Okay, this is in centimeters. All right, that's as accurate as we can be with this ruler. Now, if we upgrade our ruler, let's draw another line here. Whoops, wrong side. Getting excited. Let's draw another line to 10, like this. And this time, instead of just having 0 to 10, I'm going to draw a hash mark at every time I see a number, every centimeter. Okay, now this ruler that we have is much more accurate. There's all these hash marks that represent centimeters. And if we were to draw another line to measure, try to make it about the same length. I'll just come under here. Draw a line. Okay, if we're going to measure this line with our more accurate ruler, we can be certain of 1, 2, 3, 4, 5, 6. And then between 6 and 7, we now have to do the same thing we did up here. It's kind of like we're shrinking it down and we have to make another guesstimate between 6 and 7, but we have to use a scale of 10. So I'm going to write is equal to 1, 2, 3, 4, 5, 6. And I'm going to put a decimal. Right? And it's going to fall inside this line here, and I would say probably 4. I'd say 6.4 centimeters. Do you see how my measurement's a little more accurate? It's because I'm now using a better tool. Now, let's draw another line. I'll draw another random line here. It's a little longer than the others. And this time, I'm going to use this ruler. I don't want to draw this ruler because it's already basically given. I have it. And I want to make a measurement with it, but it's going to be more accurate than these because I have the very tiny lines in between the centimeters. So if I measure this line from 0, so my certain digits would be up to 7, would be equal to, because I'm within 7 to 8, and then I have the small hash marks, 1, 2, 3, 4, 5, hold on, 5, 6. So I can be certain between 5 and 6. So I'm going to say 0.6. And then I have to make a guess in between these very small lines. And it's basically right on the 6. So I'm just going to do a 0 because it's kind of between 6 and 7. But it's closer to the 6 right on that line. So I'm going to write 7.60 centimeters. And you can see that as I increase the amount of lines on my ruler, I'll put this here, my accuracy improves. And you notice something, that every time I do this, I have to guess in between these segments of lines, from these very tiny lines to these medium distant lines and this massive 0 to 10 centimeters lines. All right, now let's write a little notes down below. Okay, the last digit is always uncertain. I would say, or it's an estimate. Estimate. All right. It's an estimate. EST, that's usually right. Now, I'm going to underline this. Uncertain. Our numbers that are uncertain up here are 0, 4, and 6. Okay, this one only has one digit, so it's got to be uncertain. And I'm going to do the black line here. And then we have the marks are considered certain. And I'm going to do those in purple. Okay, when they're certain, they're digits that we know because they are marked on our ruler. Okay, the first one doesn't have any certain digits. It's just 0 and 10. The next one, we have a scale of 1 to 10, so we can have one certain digit that we can get us closer. And then now with our best tool, our best ruler, we can go all the way down into the hundredth place with uncertainty. All right, I'm going to write this down too. Imagine 10 lines between lines. Okay, that's the idea. These are your 3 rules. And then lastly, you can only measure to the accuracy of your tool or instrument. Okay, it could be a graduated cylinder. And I'll have an example. I have a graduated cylinder that has tons of lines versus a beaker which has a line every 100, 200, 300 milliliters. The graduated cylinder is going to be much more useful to getting a better measurement. So if we have a choice in the lab to use different instruments, we will choose the one that's the most accurate for what we're working with. Okay, so please keep in mind, these digits at the very end are uncertain and they're estimated. And the ones that are certain, that are markings on the ruler or the graduated cylinder itself, are considered certain. Okay, I think that's it for this video. Thanks for watching.